Hello. Right now I am going to explain a very important concept used in JEE. So let's understand. Suppose we have a block. Its mass is m1 and here it is moving with velocity v0. And here we have another block where one spring is mounted and its mass is m2, which is at rest. Because this is moving, and suppose at time t equal to 0, it has just about to touch the spring. I mean at time t equal to 0, it is just about to touch the spring and it is moving with velocity v0. So what will happen? Because here it has some velocity, so it will just as time passes it will touch the spring, and because of its momentum it will apply the force on that point, and the spring will start to reduce the length. So as it is moving here, so a spring will keep started reducing its length, so there will be start compression, and because of that compression it will apply a force here, and that force will directly proportion to compression, that is length, and it will also experience a force because that spring will apply the equal and opposite force. Here it will apply force and here it applies force. Suppose at time t1 the spring have been little bit compressed. Do you understand? Because of that compression it will start to apply force on that block, and because of that force the velocity of that block will no longer be 0. Because why? Because it experiences a force. Similarly here it will experience a force, and because of that force the velocity of that block will start to decrease. Why? Because the force is in opposite direction of velocity. That is why the velocity of that block will keep reducing. Suppose at time t1 its velocity becomes u1 and its velocity becomes u2. So then what will happen? That block will keep applying the force on that spring as long as the velocity of u1 is greater than u2. Why? Because as it is simple, if u1 is not greater than u2, then the length of spring will not reduce. So as long as the u1 is greater than u2, the length of the spring will keep reducing. So here it is again applying the force on that spring, and the length of spring is keep reducing. Suppose at time t equals to t0, the velocity of both the block becomes equal. Here it is moving with velocity v, and it is also moving velocity v. Why? Because this spring is applying the force on that particle on that block, so its velocity will keep increasing, and here the force is opposite to the velocity, so its velocity will keep reducing. So there will a time arrive where the velocity of both the block will becomes equal. So at that instant the length of the spring will not be able to reduce. Why? Because both the blocks are moving with the same velocity, so that block will not be able to reduce the length. So at that length, suppose that length is x0, and this is a very important, because quite often it is asked what will be the compression of the spring when both the blocks will start moving with the same velocity, or they may ask what is the maximum compression of the spring. Because here you can say here the compression is 0 because spring is in relaxed condition. Here there will be some compression, let it is relaxed, but the velocity of that particle is greater than this, So again there will be a compression again, and here both the block start to move with the same velocity. So now it has again the compression of has again increased, so there will be a maximum compression. So now let's move forward. Okay, and suppose now we have to find that velocity v. So here in the ideal condition there is no loss of energy, so the total energy of that block will be converted into energy of that block plus this spring. So now apply the conservation of energy. Half m1 v0 square is equal to half m1 plus m2 v square, because both the blocks are moving with the same velocity, plus half k x0 square, equation first. Now as you can see the force on this is here and at this point is here. So we can say that the force on this system is always opposite in direction and same in magnitude. So the resultant force on that particle on that block system is 0, because if we add the system, minus f plus f is equal to 0 by m1 plus m2. This is the acceleration of center of mass. Total force on the system is 0, so the total momentum of the system will be conserved. Why? Because there is no external force. The spring force is always opposite in direction and same in magnitude, so the momentum will conserve. So now apply the conservation of momentum. So what will happen? M v0 equals to m1 plus m2 times v. Here what we have to find out? We have to find out the value of x0. So we will replace the value of v. Now let's solve this. Now so v equals to, where is मिटारने वाला? Here. So v equals to m1 v0 by m1 plus m2, and we will substitute here from there, and then we will find out the value of k x0. So I will not do the calculation because calculation is not our aim. Our main aim is to understand the physics behind it. So I hope you understand the physics, why that happens. So now let's move further.